with our short class today, we are going to review solving equations with fractions and distributive properties. Sometimes fractions can be tricky for kids to handle, and you want to remember how to handle distributive properties before the equations start to get more complicated. So today is Monday, November 25th, and the first equation we're going to look at is 3/5 m equals -12. There are really two different ways to solve this particular problem. And I want to go over both because they're both important for you to realize. First of all, a lot of times, because of everyone's background with Singapore and bar modeling, when they see this equation, it's very natural to think, well, 3/5 m is -12, I can find 1/5 m and then m. So often kids think about this problem as a picture like this in their mind, and they know that 3/5 is equal to -12, and they want to find the whole thing. So if you can find 1/5, then you can find it all. The numbers in this work out really nice, so it's quick and easy to do this problem. And I call this the unitary method. So if 3/5 m is -12, then 1/5 of m must be -12 divided by 3, or -4. And if you know that just 1/5 of m is -4, you can multiply by 5 to get 5/5 m, or 1 whole m is -20. So that's the unitary approach. It doesn't work on all problems, but when it does work, feel free to go ahead and use it. The other way is much more just algebraic manipulations here. 3/5 is a coefficient, just like we worked with last week. Instead of a 3m, here we have a 3/5 m. Well, the same idea applies. We want to find out what m is. So to get rid of the fractional coefficient, we need to divide by 3/5. So we could say, well, we got to do -12 divided by 3/5. But remember, dividing by 3/5 is the same as multiplying by the reciprocal. So when we face a fractional coefficient like this, the easiest way to get rid of it is just to multiply by the reciprocal. And of course, it's a balance, so if you multiply one side by something, you have to multiply the other side by the exact same thing. Here, the 5/3 of 3/5, that just cancels away to 1m. Over here, we can put the -12 over 1. We can simplify to -4 there. And you see here that -m equals -20. So you get the same answer. It's two different approaches. The first approach is nice when the number is easily divisible by the amount of units you have. That won't happen nowadays. Or you have the second approach where you multiply by the reciprocal. This you'll have to fall back on more and more often. You've got to know both. All right. So then students did this next example, number 2, with their partner. 7/8 y equals 11. And the first thing they were told to discuss was whether or not they should do the unitary approach or the reciprocal approach. And pretty quickly students realized, well, 11 is not divisible by 7 as a whole number, so unitary approach will not work very nicely. That means I just need to multiply by the reciprocal. The reciprocal of 7/8 is 8/7. So I got to multiply this side also by 8/7. You can put this over 1. This simplifies to just 1y. Over here, nothing cancels. I get 88/7. I need to simplify that either to a mixed number or a decimal. I recommend a decimal because dividing by 7 is kind of yucky. So 7 goes into 88 12 times with 4 7ths left over. All right, so then we want to move on and look at a couple more examples with fractions in the equation. Example 3, here you can see 2/3 h minus 6 equals -18. What's different about this equation? Well, now we have a coefficient here. If you have subtraction, you probably want to change it to adding the opposite, the equivalent addition problem, so you don't lose track of the sign on that constant. We need to eliminate the constant. We can eliminate a -6 by adding +6 to both sides. When I simplify the left side, you end up with 2/3 h, and the right side simplifies to negative 12. Now here's one of those situations where I have 2/3 h equals negative 12. It's kind of easy to break the negative 12 down into two pieces to find out what 1/3 is, or you could multiply by the reciprocal. Either one will work. I like the unitary when it works. If 2/3 h is negative 12, then I know 1/3 h must be whatever negative 12 is divided by 2, which is negative 6. And once I know 1/3 of h, I can easily find h just by multiplying by 3. So h equals negative 18. Now you could go do the problem using the reciprocal, and you will get the same answer. All right, so let's look at another fractional, one more fractional equation. We've got 4/5 g minus 2/3 equals 1/6. All right, more fractions, fractions everywhere. That's okay, we can handle it. So the 2/3 there is your constant. Again, it's being subtracted, so you want to keep track of the fact that it's really like a negative constant, right? What can we do to eliminate a negative 2/3? Add 2/3. So we got to do that to both sides of the equation. Otherwise, we won't maintain the equality of the statement. Over here, I cancel away my constant, which is what I wanted to achieve. I'm left with 4/5 g equals. In order to complete this fraction addition problem, I have to get common denominators. The lowest common denominator is 6. 2/3 is equivalent to 4/6. So my 4/5 g equals 5/6. That one's kind of messy to try to think about unitary-wise. So it's much easier to just multiply by the reciprocal. And we'll get that g is equal to 5 times 5 is 25 over 24. But that's improper. So that's also equal to 1 and 1, 24. Not too bad, and good practice with your fraction operations. All right, let's continue on and look at a couple equations with distributive property, and then we'll call it a day. So here's example 5. We have 3 times the quantity of x plus 5 is equal to 31. So the variable I'm solving for is buried in the parentheses. Usually students realize that if they distribute, then this will become a fairly simple equation. So whenever you have distributive property, you can always distribute to get rid of the parentheses. And 3 times the sum of x plus 5 is the same as 3x plus 15. And it's equal to 31. And then that's an equation you learned how we worked a lot with last year. You want to eliminate this 15, so you got to subtract 16 for both sides, or you could say add, subtract 15 from both sides, or you could say add a negative 15, whichever way is fine. So 3x is equal to 16, and then we need to just solve for 1x, so we divide by 3, and we learn that x must be 5 and 1/3. I always recommend writing it as a fraction, well not always, but almost always, because it's just so much quicker and more efficient. All right, so once we work through that example, then students work with their partner to finish example 6, and then start at their homework. So why don't you go ahead and pause and see if you can do this one, and then check back to see if you're correct. Okay, so hopefully you paused and tried to solve it, and here is the solution. I'm going to distribute through first, and I get 8m minus 20 equals negative 54. Be careful with this constant, it's like a negative 20. To eliminate it, you have to add 20 to both sides. The left side simplifies to 8m. The right side simplifies to negative 34. We want to know what 1m is, not what 8 of them are, so we gotta divide by 8. And we will see that n equals a negative. 8 goes into 34 4 times, with 2/8 left, but 2/8 simplifies to 1/4. So m equals -4 and 1/4. This problem should set you up for doing your homework.